Okay, so I think that we can start. So first of all, hello everyone, and thank you so much for joining us today. I'm pleased to welcome you all to the Smart Water Management event organized by Forest Valley Institute. A very quick introduction about Forest Valley. So we are a no-profit organization committed to fighting climate change by driving innovation across supply chains, that is, rethinking the way goods and services are produced. So we do this through several activities. First of all, through our Sandbox program, we accelerate European B2B climate tech startups and connect them with companies and investors. Then we also work on the implementation side, supporting companies in their innovation journey through corporate training, strategy development, tech scouting, and POC implementation. And finally, we run dissemination activities, spreading knowledge and best practices on climate innovation like today's event. Well, today's session is the third chapter of our Climate Tech Frontiers event series, where we bring together startups, corporates, VCs, and public institutions to foster discussion on critical sustainability challenges and also create opportunities for collaboration. And before we dive in, I'd like to warmly thank Edison and Gruppo Cap, the partners of our event series, for their support in making this initiative possible. To open today's event, we'll hear from Francesca Mastromarino, Manager of Water Efficiency and Special Projects at Gruppo Cap, a leading public water utility serving the metropolitan city of Milan, who will present a major project funded under Italy's National Recovery and Resilience Plan, focused on reducing water losses, modernizing infrastructure, and digitizing water networks. So Francesca, please. When you want, the stage is yours. You can share your screen. Thank you.
Okay, I'll share my screen. Good afternoon, everyone. My name is Francesca Mastromarino, and I'm Manager of Water Efficiency and Special Project at Gruppo Cap, the public water utility managing the integrated water service for the metropolitan city of Milan. It's a pleasure and an honor to be here today, sharing our vision and the innovative work we are doing. Today, as Noemi said, I would like to share with you some of the experiences and best practice we have developed at Gruppo Cap under the National Recovery and Resilience Plan, with a focus on water loss reduction and digital transformation. Let me begin with a brief introduction to Gruppo Cap. We are one of Italy's largest public water utilities, managing the full water cycle from aqueduct to sewerage to treatment in the territories of the metropolitan city of Milan and in some other Lombardy municipalities. In 2023 alone, we distributed over 235 million cubic meters of water, managed 724 groundwater wells and 6,500 kilometers of water network. But let me say, we are more than an infrastructure operator. We are an agent of innovation, sustainability, and shared value. Our 2024-2028 business plan includes 611 million euros in investments, driven by the belief that sustainability enhances not only resilience and service quality, but also economic performance. Our strategy is based on three pillars. We are sensitive as attentive to the needs of communities and the environment, resilient as able to face climate and infrastructure challenges, and innovative as always seeking better, smarter, and more sustainability solutions. The vision is what guides our work on the project that I'm presenting today. The National Recovery and Resilience Plan is a once-in-a-generation opportunity to reshape public service in Italy. Under Mission 2, Component 4, the plan focuses on the protection and the sustainable management of water resources. Within this mission, Investment 4.2 targets the reduction of water losses and the digitalization of the distribution networks. Our project at Gruppo Cap was awarded 42.5 million euros in funding and represent one of the largest and most integrated efforts in the country to reduce water losses through innovation. To achieve our objective, we apply advanced technologies and an innovative management approach across 133 municipalities. This is a comprehensive transformation of both our physical infrastructure and our digital capacity. The project, in fact, combines a wide range of activities, including division of the network into district meter areas, water loss detection with innovative technologies, network modeling and creation of a digital twin using AI and predictive tools, smart meter deployment, and telecontrol and control room upgrades with integration of cloud and 5G or LoRaWAN technologies. All of this is underpinned by a strong decision support system which guides our operation and strategic choice. We are proud to say that we are ahead of schedule. Our tenders were awarded by September 2023, and all the activities are expected to be completed by December 2025, 3 months ahead of the official deadline. And by the end of 2024, more than 40% of our network has been divided into DMAs. And by December 2025, we aim to reach the 100% district of the network. The project is not one size fits all. We've adopted a differentiated strategy based on the performance of local infrastructure. A key driver of our progress is the M1 indicator defined by ARERA, which is the Italy National Water Service Regulator. M1 measures the water losses in the distribution network and is a performance indicator that reflects the overall efficiency of the network supply infrastructure. ARERA classifies utilities into 5 performance classes, as shown in this slide, from class A to class E. Of course, class A represents excellent performance with very low water losses. Class B is good, class C is average, class D indicates poor performance requiring improvements, and class E is the lowest, signaling several inefficiencies. This classification directly influences how utilities are regulated and what corrective actions are expected. So in our project, we adopted a differentiated strategy based on these M1 classes. We see that for class C, D, and E municipality, which we call the group 1, when we have poor performance, we implement deep intervention. For class A and B municipalities, group 2, that are better performing areas, we focus on preventive monitoring. We are also building digital model of large diameter transmission mains to optimize pressure, energy consumption, and service continuity. This performance-based segmentation allows us to prioritize resources and tailor technological solutions to the needs of each territory, ensuring that every euro invested generates the highest possible impact. Let's see the activities in detail. For class C, D, and D municipalities, we are developing a platform for online simulation of a digital twin that is continuously fed by data measuring in the field. We aim to know how the infrastructure works by the moment and predict network behavior and pre-localize the losses. Additionally, we have planned the replacement of the old networks for 18 kilometers. For class A and B municipalities, we are using now noise logger with the aim to record some frequencies, especially at night when ambient noise is lower and new leaks are easier to detect. For large diameter networks, we are building digital models that support real-time simulation, forecasting, and even historical analysis. This will enable a data-informed operational strategy that is flexible and future-ready. For all the municipality, we are installing flow and pressure meter for DMAs, satellite detection for early localization of the leaks across vast areas, the rollout of smart metering to increase data accuracy, Furthermore, we are integrating technologies such as the transition to a cloud-based data factory, scalable and secure, capable of supporting future AI application, and a decision support system for planning replacement and prioritizing intervention. The benefits of this project are measurable and multidimensional. For the water saving, we have 13.5 million cubic meters per year. For energy saving, over 4.3 million kilowatt-hour per year. For the CO2 reduction, over 1.6 million kilograms per year of emission avoided, and the economic impact is around 227 million euros, with the involvement of almost 2,000 full-time jobs during implementation. This is what we mean by shared value, creating positive impacts for people, the planet, and the economy. In conclusion, our experience shows that public water utilities can and must lead innovation in the service of sustainability. We are not just managing assets, but we are managing change. By combining vision, investment, and digital transformation, we are building the water utility of the future, resilient, transparent, and deeply rooted in its territory. We believe that by working together across sector borders and disciplines, we can create a real impact. Thank you very much for your attention.
Thank you. Thank you so much, Francesca, for sharing the project with us and the valuable insights that you shared, and also for setting the stage for today's discussion. Well, we'll now continue with a panel discussion to dive deeper into the challenges and opportunities in modernizing water infrastructure, that is adopting digital tools and driving sustainability in the sector. So I'm pleased to welcome our panelists. Along with Francesca Mastromarino from Gruppo Cap, we have Luca Berardi, Innovation Manager at Aquanexa. Hi, Luca, welcome. And then Hi, Luca. And then Francesco Petrosino, Innovation Professional at A2A. Welcome,
Hello,
Francesco.
everybody. Hello.
Okay, so let's get started. And please, if you have any questions for our guests, you can just drop them in the Q&A session, because there will be some time for Q&A after the panel. And so let's start. So Francesca's keynote gave us an excellent overview of the need for modernization and innovation in the water sector. So to open the discussion, I'd like to ask all of you, in your view, what's the biggest innovation gap in the water sector today, and what would it take to close it? That's a tough question. Who starts?
Okay, so I can start. So I think we think in Aquanexa we are working, as you know, we are industrial group, but now we have total 9 companies, more or less 250 people. We are create Aquanexa in order to give one-stop shop for the water utility. Our vision is output based. So we start from the mapping to the network, arrive to the relining in order to make to avoid the substitution of the pipes, but to work in safety. So the main gap for us is in this moment we have a lack of full digital integration across the network and the process and the management system. So all the operation is fragmented now, and we have a problem. The water utility have the problem because they have a different solution and a problem to reach the result. So to close the gap, we need to target the investment and the infrastructure digitalization for the new solution. I mean, the next generation sensor, next intelligent management platform, and we have to use AI in a correct way, not only AI, but we have to understand the benefit of the AI, and is also important that the company like Aquanexa, but also the water utility, invest in the new skill of the next generation people that works inside. So in order to have a more agile organization inside, and able to adopting new innovation that are coming in this period. So we cannot manage the water for the future with the tools of the past in this moment.
Sure.
Okay.
Thank you. Thank you so much, Luca.
You're welcome.
Francesca?
Yes.
Or Francesco?
I totally agree with Luca. Also, for me, the most significant innovation gap today is the integration of data-driven decision-making at scale. Because while digital tools and smart technology now are increasing, thanks also to the European funds allocated for the recovery plan, their adoption remains fragmented in Italy and often is limited to isolated case studies. In fact, many utilities may not yet leveraging the full potential of data analytics to optimize the operation. So for me, closing this gap requires a coordinated effort on several levels. Firstly, investment is needed, not only in digital infrastructure, but also in workforce training and organizational change. However, one of the structural barriers to secure this type of investment in Italy is the relatively low water tariff, which limits our financial capacity to innovate and modernize the system. And in addition, building internal capabilities, particularly in this moment in data science, is essential to translate data into insights. And also, I would like to say also that regulatory bodies should also establish frameworks that reward not only the performance improvement, but also the use of the digital innovation. And I think that collaboration across utilities and also with the private sector can accelerate knowledge sharing. So also this is more important.
Thank you.
Yeah, I agree with my colleagues. Thanks for assist me. I agree with them. We are working in A2A, and I think that the biggest innovation gap, as we said before, is the lack of structured data governance. In A2A, we are trying to address this problem, trying to centralize and coordinate different approach and the test of new technology, such as AI solution and digitalization. We are also trying to use the support of, as you showed before, the National Recovery Resilient Plan to try to create different districts along the network, every maybe 10 or 15 kilometers, in order to have a real vision of what is happening in some water management, of course. I also agreed with Francesca when we say that in Italy we have a regulatory national framework very clear, and we have KPIs as we showed before, very clear. So I think another innovation gap we need to address is collaboration, not only between startup and public administration, not only between A2A or public administration and startups, but also center research, and everything could be addressed this problem. So I think lastly, we need to treat regulation not as a constraint, but as a driven for innovation, using it as leverage.
Thank you. Thank you so much for sharing your perspectives. And in this respect, Luca, focusing on an open approach to innovation in addressing these gaps, what are the main challenges in the integrated water cycle that Aquanexa is aiming to address through this approach? And how can a strong ecosystem, as Francesco was mentioning, including startups, universities, and research centers, play a role in this process?
Sorry. So, as I said, Aquanex work in the entire water cycle, and so we are working to reducing the water losses. So make advanced monitoring or relining. We are working also in optimizing energy consumption, but because carbon neutrality is very important, but also the water utility have to reach this target, improve the water quality, because there is a lot of things to do also in the water quality that are monitoring the weather, the network. And also we are working on the extreme events. Now we have too much rain or no rain, so we have a problem with the extreme events. And also we are working with the startup, with the university, to address a new support decision system to manage the extreme weather. So in this way, Aquanex position is we found that an approach to work together with university, startup, and also with the water utility is the main key for to reach the good result. So in this our work for innovation part, that is I'm in charge, we are working together very strict to our partner, and we are looking with the startup and university, especially to find a new sensor that can monitor the network, continuous monitoring, digital platform. So we are looking at everything that is innovation that can help the water utility to reach the goal. So the open innovation is could be a strong ecosystem that all we can create and work together. We can create a strong ecosystem to reach the goal. So the water management innovation means moving from reaction to anticipation something. So I think that this strict collaboration is the key. The main key for us.
Thank you. Thank you so much, Luca. Well, Francesca, based on your experience at Gruppo Cap and also looking more closely at how innovation can be integrated in the public sector, what's the role of innovation in a public water utility today? And most important, in your view, what conditions are necessary for innovation to be successfully integrated and scaled within a utility?
Okay, so we are all aware that we live in a time of great environmental change and challenges. Of course, the climate crisis and sustainability resource management, the needs for technology innovation are issues that requires our attention and commitment. I think that in this context, the role of public company is crucial. Let me say, not only we must adopt sustainability practice, but we must also pioneer the implementation of that advanced technology that can make a difference. At Gruppo Cap, as I explained before, we have launched an ambitious 80 million euro plan to reduce water losses in all our network in the Milan area. And the project includes the adoption of advanced digital technologies for real-time monitoring and also predictive failure analysis, such as the DMS, smart meter, digital twin solution, offering an integrated approach to reduce effectively water losses. This approach, it isn't new, it comes from our previous experience from 2017 to 2021, Gruppo Cap undertook a campaign to sectorize all the network, implementing flow and pressure meter chambers and closing also the district gates. This district strategy has been at the beginning hybrid because we combining physical closure with flow monitoring through electromagnetic flow meter and data logger. They send the pressure and flow real-time data to the Gruppo Cap telecontrol. And during these years, temporary monitoring was carried out to calibrate hydraulic models and identify critical issues. This experience has allowed us to have greater knowledge of the flow and pressure within the network, to modifying the operating logic of our system with, of course, a view to lowering operating pressure while still guaranteeing the best condition for our users. And in the meantime, we have had the opportunity to experiment a lot of loss reduction technologies to understand how to best plan a 5-year plan with PNR across our entire scope of intervention. So for innovation to be successfully integrated and scaled within a utility are essential several conditions. As I said before, there must be, in my point of view, first of all, a clear strategic vision that embraces innovation as a key driver of long-term value. And also leadership commitment is critical because leader must foster a culture that encourages new technology, collaboration, and experimentation. And also, as mentioned, adequate funding and dedicated resources are necessary to support pilot projects that can be extended to all the network. Also for me, it's important the collaboration with research institution, also technology providers and other utilities, because as I said before, by sharing knowledge and fostering we can foster co-development of solution. And one other aspect is to evaluate the impact of innovation initiative. So we must monitoring KPIs and assessing performance improvement to ensure the scalability and the continuous learning. So it's also the the need to engage the staff to ensure that innovation, of course, is not seen as a threat, but an opportunity for professional development and also for the service to the community.
Thank you. Thank you so much. Sure, that's the key. Well, Francesco, keeping on with one of the sector's most urgent challenges that also Francesca was mentioning, which is water loss. I ask you, what types of technologies or approaches do you see as most promising to address it effectively?
Okay, thanks for the
Your
question.
experience in Padua.
Yeah, I totally agree with Francesca, because the challenge of water losses in Italy is very significant. We are talking about an average national dispersion rate very high, too high. So we are trying in a way with the innovation team to test and work with different technologies. They are quite everyone structured on data-driven approach. So we are trying to test installing new advanced sensor technologies, and also trying another approach which is based on AI and predictive hydraulic models. One key project we are just finished to test, and we are actually scaling on the whole water infrastructure, is called Aquarius, which is we tested it in Brescia, which is next to Milan, in the north part of Italy, and it uses fixed acoustic sensor, allowing us continuous network monitoring. So they are able to hear the noise of the water losses and alerting us where it is. Other two technologies we are testing in parallel are one technology is based on the detection of neutrons generated by cosmic rays. It's really difficult to understand, but it's a technology which is already known for 20 years. So we are trying to test it in an innovative way in order to measure in real time the soil moisture. While we can count the number of neutrons, we can count also the water loss. So we are using it mounted on a moving vehicle in order to map all the underground water in order to identify potential risk zone without having an excavation. Another solution we are testing actually is a permanent repair for water pipelines. So using high performance composite materials. This is actually a wrapping technique in order to have a definition of repair intervention on the first attempt, but I don't want to spoiler anything because you will heard about it later. So I will leave then to my colleague the word. So we are trying to test these new technologies in order, of course, to demonstrate our commitment to have an efficient and more sustainable water management, hoping that this technology will have a real impact on the water losses and optimizing the use and the distribution of the water of resources.
Yeah. And talking about impact, Luca, I'd like to come back to you briefly. So before you talk about open innovation, and I ask you, which is a topic that both Francesca and Francesco were raising, how do we measure the impact? I mean, how do you evaluate the impact of open innovation processes, but I would say in general, innovation projects, both in terms of, on the one side, environmental sustainability, but also business performance on the other side?
Okay, so there are, I think, maybe two main dimensions for to measure this impact for me. One for sure is how the open innovation can help to reduce the water losses. Okay, for this is the main for all the water utility are working on it in these 3 years. But we have to also to take care to monitor the energy. So the new innovation have to work also with the lower consumption for the energy. Minimize the chemical use. Now the water utility have a high cost to use a chemical for the disinfection and also for everything in the process, and for sure to decrease the CO2, the carbon emission that is a mandatory for all industrial. For the business performance, the innovation, the new innovation, the open innovation have to able to reduce the cost for sure, and the new solution is able to do this. So improve the service level. So the new solution for monitoring the quality for the water we will see after with the one of the people in the side is able to improve the service for the quality and minimize the cost, minimize the chemical use. So is increase, and this means increase the return of the investment. So we evaluate the open innovation in this means. It's important also that the innovation is not an opportunity. Is have to be a new standard for the sustainability and for the competitiveness for all the water utility and also for the private company.
Yeah, thank you so much. Francesca, let's touch on another important aspect that is the broader environment where innovation happens. So I ask you, in the Italian context, what are the main barriers, being them regulatory, technical, or cultural, also, as you was mentioning before, that slow down the adoption of digital technologies in the water sector?
Okay, I can talk 1 hour, but I will have a brief question on all. From a regulatory perspective, we mentioned before the fragmentation of the governance, because the water sector is managed by numerous local utilities, and often these utilities have varying levels of maturity, technical capacity, and investment readiness. So this fragmented landscape can result in inconsistent application of national regulation, delay in the authorization process, and the lack of planning. Moreover, the framework in Italy does not always provide clear or sufficient incentives for innovation. As I said before, the National Regulatory Authority has made progress in promoting efficiency and transparency, but its mechanism focus on cost containment and service continuity. So there's a relatively limited financial incentive tied to the digital innovation. Another issue from the regulatory point concern the procurement procedures, because the system in Italy is often complex and rigid, and it makes it difficult for us to engage in experimentation or to quickly adopt a new solution. And of course, this is critically when we have to deal with fast evolving technologies such as AI, IoT, or real-time monitoring, which requires speed and flexibility. On the technical side, a major barrier is the presence of outdated or maybe inadequate infrastructure, because in Italy, all the networks are decades old and they are not designed to support digital integration. So it's necessary retrofitting these elements to accommodate these new sensors that we are talking about, and also requires, of course, significant investment, and in some cases also structural intervention. And this is often also a lack of standardized digital architecture across utilities, which hampers the interoperability and makes it difficult to scale the sector. From the point, the human, the cultural point of view, utility often face difficulties in recruiting on retaining staff with the necessary digital competence. And of course, technical personnel may be highly experienced in traditional operation, but may lack training in data analytics, cybersecurity, and so on. So without a reskilling strategy, digital transformation is isolated in initiative with no real systemic impact. And also, of course, the resistance to change remains an obstacle, because many organizations adopt a conservative approach, let me say, preferring traditionally methods over the new untested technology. And this is a mindset that is it's due to the nature of the public service, where reliability and continuity are essential, but it can also reflect a lack of familiarity with the potential of the open innovation. So changing this culture requires, as I said before, a strong leadership, a clear innovation strategy for the long term, but also this includes field operators and also administrative staff. And despite these challenges, there are also positive developments, as we said, in the PNRR has allocated important resources in relation to water losses and improving new technology for the digitalization. However, to access to these funds requires both administrative capacity and strategic readiness, which of course not all utility currently possess. So is required support, knowledge sharing, and coordinated action between all these stakeholders to unlock the full potential of digital technology in Italy. Of course, this will depend on the creating the environment, that aligns all these point of view, so regulation, investment, infrastructure, and organizational culture. Of course, this is not simply a technical challenge, but I think that a governance challenge that can bring a systemic change and long-term commitment.
Thank you. Thank you so much, Francesca, for sharing a very detailed perspective and overview of the barriers of the sector. And finally, Francesco, let's look ahead to how predictive approaches can reshape operations in water infrastructure, and then we'll see also later in the startup session. So we can say that predictive maintenance is also gaining a momentum across utilities. So I ask you, what potential do you see in this approach, but especially what are the key implementation challenges in complex infrastructures like water networks?
Yeah, thank you for the question. Yeah, I think that potential predictive maintenance in the water sector is enormous. Predicting failures or degradation in performance of our assets enables utilities like A2A to, of course, reduce cost of maintenance, to reduce unplanned service disruption, and to improve operational efficiency. Not only from that, we also have fewer failures, and we can rely on somehow the longer asset life. In a way, we are investing in this transformation, so trying to adopt some predictive maintenance technologies, and always the challenges that we recognize and that are must be addressed are also always data quality and availability. So the disposal for data, the system integration, because of course every asset is managed also by our control room team, so team of asset management and asset performance. And from an internal point of view, in my opinion, also the cultural shift. So we must move from a fix after failure mentality to a prevent before failure mindset. So this will require, of course, internal training. I would like to bring an example, always in the same territory as I said before. In North Italy, we are actually starting, and there is an ongoing pilot project, in collaboration with our colleague of Water Cycle and an Italian startup that I see in the question that our listeners are mostly interested in startups, so maybe we can also answer later. This pilot project is focused on predictive maintenance of hydraulic and electromechanical equipments, such as water pumps and compressor in our wastewater treatment plants. So our idea is to install the correct sensor, so the correct hardware, like vibration sensor, temperature sensors and mechanical strain sensor in order to detect any anomalies. So there is also the integration of machine learning and AI in these systems, and a software that can alert us when this will happen. So when our equipment is going under fault, so to prevent it in order to create any benefit that I said before. So this is only an example of predictive maintenance. We are trying to understand if the technology works, and then the idea is to implement and scale up in every single plant we have. So I think this is a good example and a good combination of innovation, data, strategic partnership with also startups in order to enable a smart and resilient water infrastructure.
Thank you so much. Well, we have a couple of questions from our audience. So the first one is, how are you using artificial intelligence in your work? I think, Luca, you can go first.
No, I'm not a specialist of AI, but we are working. We have a different solution that use AI, anomaly detection. So a system agnostic that can read information and understand if is correct or not, and to prevent to make a predictive answer for the water utility. So we use AI for different aspects. So anomaly detection, but also for, as Francesco said, for the vibration on the pumps and to understand the maintenance, predictive. So there are a lot of using of artificial AI, but we have to take care because too much AI means that we need a lot of data, and the data is not always good. And also to use AI means that we have to use a lot of water. So we try to make a balance to use AI, but also to physical model.
Thank you.
You're welcome.
I can bring the view of Gruppo Cap. Of course, we also use AI for the website, for the customer service, but in technical issue, the most application that we are running now is the predictive analytics for the decision support, because in our vast area, as Luca said, we have to analyze large volumes of real-time and historical data from sensor, flow meter, smart meter, noise logger, and so on. So this allows us to detect anomalies, predict leakage, and identify inefficiency. Of course, in a very less time that a human can do. And also the implementation for our digital twin platform, which simulates the behavior of the network in real time online. And this enables us to forecast network performance under various scenarios from the network and also from the implant. So we can make informed decision on maintenance, also the pressure optimization and energy saving.
Thank you, Francesco.
Yeah, I don't have much more to add from after
sure.
my colleagues. I can say that we are quite young as in the innovation team in A2A, and we have just created a new team called AI Factory, which will, of course, address everything related to artificial intelligence. So they will support us from every single point of view, as my colleagues say before, digitalization, digital twin, anomaly detection. So we will support us in nowadays work.
Okay. Next up, what's the role of startups in speeding up innovation within your organizations? Is it relevant? And maybe we can link the other one, which is related, we can say. How much do you invest in scouting new technologies, and what kind of channels do you mostly exploit?
Okay, so I start. So Aquanexa, we have 5 pillars in our organization: infrastructure and plants, data measuring IoT, network engineering, and also digital platform. The fifth is the open innovation. So I'm innovation manager. We invest money and time for sure to find a new collaboration startup, but not also startup. And we have also inside our organization a colleague, let me say colleague, that is a venture capital, that is work only in the climate tech environment. So we are in constant contact with this guy. That, for example, in the last 2 weeks, they passed me more than over 100 startup in final stage to understand which startup we can become strategic partner or buying a new startup that have to be inside the Aquanexa group. So it's very relevant, and we invest a lot of money and time.
Of course, also in Gruppo Cap, startup play relevant and strategic role because they bring new perspective and emerging technologies. So we are actively collaborate with some startups. The form is pilot project and also technology scouting with some group. So we engaged with specialized partners that monitoring the trends globally and connect us when they have relevant solution. And the first step is to test the new solution directly on our network with pilot project that can be scaled up.
Francesco?
Yeah, I think it's my turn. So yeah, we like a venture clienting approach in our A2A ecosystem strategy. So we actually leverage on different actors, not only on startups, but also university research and scouters and innovation channels, which can be actually scouting platform, crowdsourcing, or knowledge-based platform. So the idea is to use our internal and external challenge to address problem or particular business need. Going to the other question, yeah, I can see investment in scouting are gaining a lot of relevancy. Also from, as we said before, the European funds, but also from our CVC corporate venture capital analysis. There are a lot of different investments and emerging technologies, of course, under the ESG point of view, also in modernizing the water infrastructure and to address climate change that we are looking for and are gaining vision everywhere.
Yeah, and maybe a couple of insights from Luca and Francesca for the other question that we received. How much attention are you recording from the financial world of innovation and investment potential in the world of water management?
high intention because, as I said, Aquanexa is an holding. The main investor is economic in fund. Inside there is a venture capital, so they put a lot of money in this venture capital for the climate sector, and this guy told me that in Italy we don't have a lot of venture capital for the climate tech, but around the world there are a lot of attention for the water sector, and we believe that we have to put a lot of attention, and we put a lot of attention and money to the investment, to the potential investment in the water sector. There are a lot of investors. Our owner is one of these.
Francesca?
I know that in other region of Italy, as let me say, innovative financing are being employed to attract private investment into the water sector. I think this is the case for Viver Acqua, which is another utility that is raising a huge amount of million. So we don't have direct experience, but I know that in Italy this is quite improving.
Okay, and then we have a last more technical question. Let's say, is it possible to monitor the flow of hydraulic pumps in underground channels, like an outdoor hydraulic pump for irrigation?
Good question.
Yeah, I think so. I mean, we are doing this control on big industrial pumps. So I think you only will like you will necess a flow meter or a smart pump controller in order to say to control it, even if the pump is not really accessible. I think it's
now there are a lot of so we are in approach with a startup. No, it's not more a startup, but they also works in with the AI, with the sensor, special sensor to monitoring the underground pumps, and so they are able to understand if the pumps works correctly or not, and also is also now with the AI and also some with the vibration. There are some studies that are looking that understand the vibration and correlate the vibration with the flow and measure the flow. So I think that is possible. I'm not a specialist, but I think that it is possible, and some company already do.
Okay, thank you. Thank you so much for trying to answer this question. Well, we still have a few minutes, so before I close, I'd like to hear a couple of final thoughts from each of you. My first question is that, well, we discussed a little bit about the role of open innovation and collaboration with startups and other ecosystem players. But I would like to hear your perspective about other ecosystem players like startup accelerators and incubators, in which relationships or partnerships are you with them? How do these kind of collaborations position themselves in your innovation strategy?
I can start as you want as my colleague. Let me, as I said before, because I was mentioning the venture clienting approach. So incubators in our innovation ecosystem are really important. We are trying also internally to create somehow similar team, which is specialized in not really incubating, but from an internal entrepreneurship. They are called the corporate venture builder. So I think it's not the first time you can listen to this word, but the idea is to create some internal call for ideas or internal challenge in order to understand if there is anything addressable internally. Then, of course, one of the most important player in our ecosystem is incubation, and we have a strong partnership with these organizations, so we collaborate quite well with them.
It's the same for us. We have launched over the past few years and participated in call for ideas, also hackathons and innovation challenges. And we also maintain relationship with university, linked incubators and technology hubs. We have a strong collaboration with the University of Politecnico di Milano and also the University of Milano Bicocca. And we not only scout new technology, but also co-develop them in certain case.
Also, we are quite new, but it's the same philosophy. For example, we are working with the Competence Center for Technology Approach, that is in the center of Italy, but we are collaborating with the university. And we have also co-development with some water utility. So the approach is the same that Francesca and Francesco said before.
Okay, and well, so to wrap up the panel, so we talk about the gaps, barriers, and the opportunities throughout the discussion. And I ask you, if you had to choose just one priority for accelerating innovation in the water sector, let's say over the next 12 months, for instance, whether it's a policy shift or a specific technology, what would it be and why? I know that this is a tough question.
Only one.
Yeah, and why?
And why? So for me, it's not a question of technology, because there are a lot of technology around the world. I would like that the people inside the company, that is water utility, but also the private company, the people have to grow up in order to understand that the innovation is the new standard. So I think that we have to improve the skill inside the people, and have a more approach to the environment, to respect the environment and the water. And so it's for me is that the skill of the people and the high level of manager have to believe that the innovation is the possibility to reduce the problem inside their company.
Okay, thank you.
Can say that I agree with Luca, but of course I need to choose one another. So I will choose data-driven strategy, because I believe that information is power. And when we truly understand our network, its behavior, anomalies, we can act proactively, as Francesco said before, and not just in case. So I think that a data-driven approach supported by all this technology that we're talking about enables to make better decisions.
Thank you. And finally, Francesco.
Yeah, I agree, of course, with my colleague. And as I said before, one of the leverage that I will choose would be the regulatory incentives. I mean, in the water sector, which is dominated by public regulated entities, innovation is not so easy. For low profit margin or risk aversion or long investment cycles. So I think an incentive regulation can create a more favorable and sustainable environment for the adoption of new technologies, to unlock investments, to reduce the inertia adoption in general. I always am taking to consideration example outside from Italy. So like in UK, there are a lot of competitive funds. In our era is just experimenting these mechanisms, as we said before. So I think this could be a good driver, a good regulatory framework.
Thank you. Thank you so much, Luca, Francesco, and Francesca, for sharing with us these very valuable insights. And well, after discussing innovation needs in the water sector, now it's time to hear from 4 startups driving new solutions. Also, at the end of this session, there will be time for the Q&A. So if you have any kind of questions for the startups that will be presenting, just drop them in the Q&A section. And well, first, let's welcome Asse Sorbeken, CEO at Aqualarm, tackling real-time microbial monitoring to improve water quality and prevent contamination risks. So Asse, please take the stage.
Thank you very much. Thank you for having me. And I really enjoyed this discussion. I think it is very, very competent and wise. I'm happy now to present our stand and situation on this. I have a 25-year background with working with safety within oil and gas. That includes process management, but also a lot of other issues. But my main interest has always been in trying to work on complex problems with a lot of causes. And that fits well with what we are doing. We are working on water quality in the span from water treatment plants through mains, through storing water ready for delivery, all the way down to the customer site with chlorination, optimization, etc. And our basic thinking and understanding is that it isn't difficult to convince people to start using modern AI-supported tools, because we only answer the questions that the personnel have. What is happening here? Where does this problem come from? What is influencing it? Which are the causes? What can we do? These questions are the questions that we answer. And those answers will enable a shift from a reactive, always on the run, working overtime, fixing problems, instead being in front, upfront, proactive. And people are happy with that. They want it. So this is not a big, difficult shift, but it takes some changes in mindset. I'll try to tell a little bit about how we do this and what we do. And it's a route in development, but also in practice right now. So I think that you recognize the problem situation with quite a lot of data, and we actually need customers that are, like Francesca said, future ready. We need a lot of raw data from GIS systems, from SCADA systems, and we can use those data in a very useful way to create insights with them. And the core is up to the right, the complexity. If you have 15 causal factors that will create problems with your water quality, and these factors may interrelate with each other, so that 2 or 3 of them, when they meet each other, they sort of blow up to a huge problem. This is outside the mental capacity of a normal person. This is work for artificial intelligence. And now this is easily available. And the fun thing is also you can talk with the artificial intelligence. That's a layer that you can easily put on a lot of hard, say, statistical and mathematical work. capacity restraints or budgets, but probably mostly manning to cope with all the problems seems to me to be a common problem around. It's so much work with fixing problems, and the combination of understanding these complex risks and the need for something close to a competence system is our leading understandings for what we do. We try to gather insights that really help in the daily work, making digital data elements come into wisdom. So that's the challenge that we are working on. The normal slow quality systematics with taking samples, waiting for the data, getting the results after water has been consumed is not something we want to challenge. And we don't try to change it. We think it will change after 10 to 20 years when things that we deliver and we all deliver together will change the regulations, but we don't take that burden on changing it. So I've set up a comparison package here, which is not fair to the other actors that I put up, but it's mostly to tell how we think that we have to gather and treat information and able to deliver information that ends up with better efficiency. That's the core. Better efficiency is our core to help any water supplier or water actor that wants to handle water at a certain quality and have it delivered at the lowest possible cost, monetary, but also environmentally, energy usage, chlorination, residuals, etc. Reduce all these to the lowest possible level. But to do so, our understanding is that you have to have a good package of data elements harvested from GIS, from SCADA, from risk reports, etc. This is a basis. You have to have good data. And good is also an important part there. Proxies like oxygenization and color of the water are very weak proxies. So for example, for microbials being maybe half of the problem to take care of, we need data on these. In some cases also then, of course, chemical toxicology data elements. And you have to work on these data with a data system that uses AI and the best possible tools that you can to make smartness out of these large packages of data. So some companies here not handling them fully well, I'm sure they would protest, but we would say that, for example, Veolia and very many other large actors have not really been able to upgrade on a complex gathering and treatment of data like this. So we have lots of actors that are interested in our kind of solutions, and we want to cooperate with many actors in delivering this. PlutoShift, as an example of a clean AI company, does not have enough on the details and qualities here. Orb, as a sensor provider, has a super good sensor, but really lacking, well, really providing much of what we call is digitalization phase 1, which is bringing the sensor data to the control room. We are trying to bring elaborated data into wisdom into the control room. We want to take away that room behind the control room when you have 10 people to understand what is happening here. That's what we want to answer. Infotiles is a Norwegian company that are actually fairly good on this, but we think that they lack some of the sensing data. They actually work with sensing data in electrics these days and starting getting somewhere. These are just examples. So in short, we gather a lot of data from customers. They have to be fairly mature on the IT side, future ready, as have been said here. We add some sensing data, microbial sensing, as an example, but in some cases also some chemical sensing. And we work on advanced data science to enrich this, to deliver Aqua Insights. And how we do this, I'm sharing a bit, but not so very deep on how we do it. We basically work with a team, highly skilled team with water engineers, risk engineers, data science engineers, and build a basis there. And we also know a lot about sensing, because we need to combine sensing knowledge to fit the sensing data properly to the need that is the data science. That's our core direction of priority. So one of the steps is basically understanding for a particular asset, a service reservoir, or a set of mains, or a water treatment plant, which are from a science basis, water, risk, and data science, which are the most important causes of quality deterioration. So we work this through going through best practice documents, risk documents, scientific documents, and we trawl the web and standards. And based on this, we set up importance scores for various influencing factors, so the causal factors. And these are actually in our delivery. So when we deliver a solution and we find a trend going towards poorer quality, you will get those causal factors that we measure in the system and inform these are the causal factors in these places, you need to act here. So this is basis for setting up our vectors. This is the basis for our mathematical constructs, our algorithms. These algorithms are always wrong in the beginning, and we use AI and machine learning to correct them and adjust them. I won't tell you exactly how now, but we also use other layers of software, ensuring that your personnel can talk with the software, ask questions. How does this relate to this? What can I do with this? If I do this, what happens then? All these things are fairly easy for us to put together. Very user-friendly, very easy. So basically our stack is a combo of the main thing, which is what we sell, the information, Aqua Insights, and everything that's behind that, which I just told you about. Then we had to add a sensor, and we made a spectrometer, a fluorescent spectrometer, recording tryptophan as a proxy for, a very sharp proxy for total cell count. Reading twice a second. It's a cheap sensor. It has low costs in maintenance. So the cost in a typical business case is less than 5% for the sensing costs. And we have a sampler. So water passing through the sensor will travel in here and sometimes out and to drain. But when the sensor sees a spike that is unusual, or the model doesn't quite understand why is this sensing situation happening.
Sorry, Asse, if you can slightly accelerate, because we are quite late on time.
Little bit faster. Okay. So you're seeing there's a sensing device, there's a characterization device to understand exactly what is happening. And this is right now in use in Welsh water, where they work on the elements down here. So what is happening? Where does it come from? Can we understand the risks and what to do? So the system is upgoing with early warnings and event management advice. And a typical rollout is understanding the customer priorities. We always work with cases where there are costs related and known for the customer. And our main sort of steering factor is reducing those costs and agreeing to focus very sharply. And we usually start with simple, sharp initial phases with not a large problem, but learning people how do the sensing devices work and how do these dialogues about how to build or use or select a model that fit their problem. Once that's set, we can usually copy the model and solution to the rest of the similar cases and also towards other customers. So typically we would save in the UK a lot of penalties that we take away. And in other markets, we will take some time until we really provide a lot of benefits on process savings. but over more time, we will also be able to do capital saving. So when is it smart to maintain this asset? When is it not? Based on the situation that we gather deep knowledge of. So the combination of process and capital savings, and in some environments also penalties, we see on a 1 million population water utility, 400% return of investment. This differs, and the numbers are higher in this case, which is brought from the UK, but still very good return of investment. So we have a very strong team to gather this, and we have a very strong team to be able to set up collaboration systematics with customers and partners.
Thank you. Thank you so much, Hasse. Of course, if our audience is interested in learning more about Aqualarm, there will be a chance to get in touch. And now next we have Sean Nelson, CEO at Freevex, offering IoT solutions for Legionella risk management and water savings.
Thanks, Naomi. I believe there was somebody before me, unless the agenda has changed. I thought I was third, but that's fine if that's
Sorry, I think I inverted. Would you want to go first, Beatrice? Do you have any issues?
I don't mind.
Sorry.
No, as you want, just because he mentioned this, as you want.
Okay, Sean, please, you can go.
Okay, well, thanks for that. I'll try and keep it very, very brief, just to share my screen here. Share screen. Can you see that okay? Yeah.
Yeah, perfectly.
Yeah.
Thank you.
So the solution I'm wanting to talk about very briefly does not relate specifically to the infrastructure of the large utility companies and their technology. It's more focused on the end user, the people who are using water, and specifically for compliance purposes. So we have focused on an issue that's very common to all public buildings, hospitals, schools, manufacturing airports, everywhere, which is the compliance for Legionella. This is undertaken. It's primarily a manual process. It's undertaken every week and every month in buildings all around the world. And it's very, as opposed to water losses, I would say this is more about water wastage. So currently, the way of managing the risk of Legionella is to monitor the outlets, monitor the taps in the building at certain places, and to ensure that water is not stagnant, so that it would be flushed on a weekly basis, sometimes more in healthcare settings. Normally completed by facilities management companies, and it's very, very expensive, inaccurate, very resource intensive, which I hope to show you soon. We've developed an IoT device that we locate in a building at a particular outlet. So you'll see here it's a wash hand basin, and it could be in a school, a hospital, anywhere, where we monitor the temperatures of the hot and cold water using our battery operated IoT device. But most importantly, we also then, I suppose bidirectionally, we can control valves that are located in below these outlets. So what we have actually managed to develop is a way of determining when an outlet is not compliant, and only necessarily when that outlet needs to be flushed or water moved. So this is an example very, very recently showing the movement of water in a healthcare setting. This is in a clinic in Bristol. It's showing 1 week's water. You'll see there on the left-hand side, I think that was probably Easter Monday, where everybody was off. And at the other side is the weekends. But what that tells, and our system will monitor that outlet, that's a very healthy profile of an outlet. Now, without that data, somebody would have went along 2 times per week, turned on the hot, turned on the cold taps, let them run for 3 minutes, which we estimate is about 240 litres of water, would on a bi-weekly basis have been flushed down the sink, literally down the sink. Because half of that water is hot water, it had to be heated to a temperature of 65 degrees. So we estimate that between 80 and 90 outlets in all buildings are healthy, are compliant. But without the data and without the knowledge, somebody will sort of go along to those outlets and manually turn on the taps and waste and flush that water down the sink. So that there's an example of a non-conforming outlet. We reckon maybe 10 to 20% are like this here. So that's water's not moving. Sorry, I should have said all of those spikes that you see, hot and cold movement, that's the water being used. That's somebody washing their hands, maybe making tea, maybe a cleaner running water for purposes washing hands in the clinic. Every movement there is, every spike is a movement of hot and cold water. That's an example of water that's not moving. So that's a non-conforming outlet. And if you see in the bottom right-hand corner, there's a small button called flush. If I was to activate that button, I can remotely release the valve at that outlet and draw in fresh cold water in this case. So we're trying to automate Legionella compliance to increase sustainability, eliminate what we call blanket flushing. Is where in a building somebody is told to go along to 10, 15, 20, 25, maybe 30 outlets and just literally turn on the taps and let the water run. So we're tackling the issue, I suppose, from the user's point of view as opposed to the provider. Costs can be substantially reduced. I'll show you a couple of case studies here. So this is the Welsh Parliament buildings in Cardiff. So this is the government buildings in Cardiff. After COVID, they set up a regime because the building wasn't being used as much for somebody to go along and literally turn on all the taps once per day, just because they weren't sure if they'd been actually used or not. When they installed the system, within a very short space of time, they were able to identify just those outlets that required flushing and were fit to reduce their water consumption by 1.2 million litres. This is 2 buildings. The energy saved 6K because they were heating a considerable amount of water that was being wasted. The carbon associated with heating the water is obviously a big factor too. And in terms of having staff doing a very menial task, this also reduced considerably the staff costs. It's a project we just kicked off there about 4 weeks ago, so we only have 4 weeks of data, but this is a very large new office block in the centre of London. Now, this only relates specifically to one floor of the building where they have 146 shower units. They're using potentially 1 million litres of water per annum, unnecessarily heating water and extensive labour costs also. So we're monitoring those 146 outlets, but already with 4 weeks data, we've saved 45,000 litres. Doesn't sound like much, but it's 600,000 litres potentially per annum, and labour savings as well. So as I was saying, our objective is to tackle the issue from the user side. And Legionella compliance applies to almost every building where the public visit: schools, hospitals, nursing homes, airports. And as you'll see there, we're working with utility companies like Northern Ireland Water, Syngenta's an agri-chemical business, OCS, these are facilities management companies, and it applies to everybody. But we believe that we can tackle water wastage for compliance purposes from the user side. So thank you very much.
Thank you. Thank you so much, Sean. And up next, finally, Beatrice Carolina Iaia, CEO at BioTitan Nanotechnology, working on water-based nanotechnology for sustainable cleaning, maintenance, and protection. Beatrice, the floor is yours.
I forgot the audio. Okay, so now I will share. So I'm really glad to be here today. So as you said, my name is Beatrice Iaia. I am the CEO and the founder of BioTitan Nanotechnology. And today I will talk about water consumption in food industries. And I will show you how nanotechnology can really change the benchmarks. So food companies spend a lot of time, a lot of money, and they generate chemical pollution and risk for health to do the cleaning and the maintenance of their workspaces. And I want to share with you some insight, in the food industries, up to the 60% of the water usage is dedicated to washing and sanitizing operation. That it's a lot. And just to mentioning one, meat processing plants consume 15,000 liters of water every ton of meat that they produced. And maybe you know this, by 2030, all the food companies has to reduce the water consumption by 30% to be compliant with the European regulation. And on average, in general, industries, not food industries, they waste water. They use liters of water to clean the 90% of global fresh water used in industries, especially heavy industries, and they spend a lot of money, like 100,000 money just in water expenses. So this is a lot of waste, you know, this is a lot. But what we did, we have solutions. So my company created 6 nanotechnological formulas to give properties to everyday material, indoor and outdoor. We give long-term guarantee, but today I want to focus on the solution for these food companies. So the antibacterial, antiviral treatment that lasts 2 years on surfaces. So using this product, you know, companies can really start saving water. So they solve the problem in food companies, and the motivation why they use a lot of water is bacterial contamination. So they have Legionella, they have Listeria, they have Pseudomonas, and they have to control it. And so they clean a lot. Using our product, they can solve this problem of contamination, they can neutralize it, and they can also save water. They can reduce the using of detergent, they can reduce the emission and also the risk for health. So they can cut the 70% of the water waste, and also they can have 30% of reduction in emissions. That it's really a lot. So our products are water-based. So this is something important in chemical words. It's not that easy to be water-based. We give these long-term properties. We have all these products patented and certified, and we are already on market. So companies, especially food companies with this product, choose us because they can save money, they can save time, they can save workforce, but they also can save, of course, water consumption, they can save detergents, they can also reduce the chemical pollution and generate safer and healthier spaces, workspaces. This is a case history that I really love. So this is a food production plant in Italy. It's a well-known one. We did the treatment with our antibacterial. So before using our product, they used to do 6 cycles of cleaning per day with chlorine. After using our product, now they do just 1 cycle of cleaning per day without chlorine. So they solved their problem with Legionella in this case. So they really had a big problem with Legionella that is really common on cheese production. And also in 2 years, they saved more than 300 liters of water, 20,000 euros in detergents, 50% of the workforce, and 70% of chemical pollution. So thanks to our solution, they had a 70% cut in water consumption that compared to traditional method, it's really a lot. And I think this is a huge step, you know, for innovation and to the future. So our business model is based on, it's a B2B, so we supply big companies. You can see some of them here, some current customers, closing customers, and from 2026, we will become also a B2C. This is the team, is led by me. I'm always really proud to show them because this is the real work that we do. In the last years, we also won a few prizes. We are really proud, especially for innovation. So we are really proud of this. And the future is in the hand of people that can look forward. And for sure, we are the future of maintenance and cleaning. So if you want to learn more and maybe understand how much you can save, just let's have a call and meet. Thank you very much.
Thank you. Thank you so much, Beatrice. And And finally, we have Michael Bertolone from Composite Research, who's developing flexible pipeline repair solutions to help reduce water losses.
So good evening, everyone. My name is Michael, and today I'm representing Composite Research. We are a small medium enterprise that deals especially with the research and development with a big focus on composite materials and its relative application in the field. So before I'm gonna share my.
Yeah, thank you.
Here we are. Okay. So before going into the deep, I want to start with a really short overview of what the situation here in Italy. So
sorry, Michael, I think we don't see the presentation, but we just see your folder. I don't know if you share the
sorry.
right.
Okay. You don't see it?
No, can you maybe stop sharing and retrying sharing, just sharing the tab with the presentation? Okay.
I don't know why it's not working now. That's pretty interesting.
Okay. It doesn't work, but
It was working before, so we try it.
yeah. Yeah, I swear. However, if you want, you can start and I will try to share the presentation for you.
Okay, thank you. So as I was saying, I like to do a really quick overview. So in Italy, water losses represent almost 42.4%. And this is if you go, is that just an average, but we can reach up to 70% if you move more to the center of Italy or the south of Italy. So this is mainly due to outdated infrastructures and ineffective traditional way to repair everything. So that's why last year, in collaboration with A2A, we decided to develop a new innovative watercolor that can be applied on water pipes with an existing leak of 5 bars and that can resist up to 16 bar of exercise. So let's go a little bit more into the deep. We have the inside part that is a certified rubber gasket that is certified to be in contact with the potable water and has a special cells inside that won't impact on the fluid dynamic of the water. We have the external part, which is a composite shell that is made with a glass fiber and a polypropylene matrix. And even this one is already certified to be in contact with the drinking water. And then we have the last part, which is the sealing. So the product is going to be adaptable to different diameters, ensuring a really easy application. Let's go. Are you able now to share or?
I think, are you looking at my screen?
No. Oh, okay. Oh yeah, I'm seeing mine. Okay, perfect. Okay, so let's go with the advantages. So with only 4 sizes, we're gonna cover pipes with diameters that goes from 21 until 255, with the possibility to do on a request, like a customized project as well. We have operational efficiency. So what we mean, we have a really compact, really compact design that is going to optimize the transportation, storage, and it can be used by a single operator. Let's talk about the permanent repair. We define permanent because in our laboratory we have all the climate chamber as well, so we can test and see how our composite materials reacts with the pass of the time. So we can say that the new watercolor is going to ensure superior longevity and a really extended reliability. And the last but not the least is the weight. So it's going to be really, really light, and compared to the traditional watercolor, it's going to weigh 50% less than the traditional ones. If we talk about materials, so it will be possible to be applied on different materials that we can find in different infrastructures, such as steel, PVC, HDPE, and many others. And we can repair something like cuts that can reach 20 centimeters large, cracks, leaks, and deformation. So this is pretty much everything. As we know, water is something that we have to preserve. In Italy, I'm talking about Italy now, every single person consumes almost 200 liters per day of water, considering that just like a shower of 5 minutes, we waste between 60 and 70 liters. And considering the average of losses that it's like 42.4%, it's like while I'm drinking a glass of water, I'm wasting another one at the same time. So this is why we sat on the table with the A2A saying we got to find a new solution that has a really less impact on the environment, and we got to do it fast. So by the end of the summer, probably more September or the beginning of October, we're going to have the first prototypes that we're going to test on the A2A infrastructures. But we are like open to have like some requests from other companies, such for example the CAP group. If they want to participate with us, we are open to test our new alpha prototypes on their infrastructure, for example, with a consideration at the end, because everything is going to be pre-ordered by the end pretty much of the year. And yeah, as we say, join the revolution. Here you can have all my direct contacts, and feel free to contact me. Thank you.
Thank you. Thank you. Thank you so much, Michael, for your presentation. Well, I think we are out of time, actually 10 minutes late. So first of all, I would like to thank all of you for participating today, and to thank all the speakers and the startup founders for sharing their insights and for their contribution. Right after this event, you will receive the full event recording along with other informations to stay engaged with us, along also with some information about the startups that you saw today. So wishing you all a good evening or a great day, depending on where you are. We look forward for sure to seeing you at the next event by Forest Valley. So thank you once again. Goodbye.
Thank you. Bye-bye.
Bye. Thank you.
Thank you.
Bye-bye.
Bye.
Thank you. Bye. Bye.